Hello everyone. In this video, let's discuss about dynamic memory allocation. Okay, memory allocation can be done in two ways. One is static memory allocation, another one is dynamic memory allocation. So static memory allocation is done by the compiler itself. So memory for the program will be allocated by the compiler itself. When you go for dynamic memory allocation, memory is allocated by the user. So that is, we programmers will be allocating the memory for the particular program. So to allocate memory, we will be using four functions. First one is malloc, next one is calloc, next one is realloc, and the last one is free. So the function malloc and calloc helps us to allocate the memory. Okay, realloc function helps us to reallocate the memory. If we have given extra space, we can reduce the space. If we have given 2 blocks of memory, but I need only 5 blocks of memory, so I can extend the memory. So whatever the change we want to do, that can be done by using the realloc function. Free function helps us to delete the allocated memory. So these are all the four functions which helps us to allocate the memory dynamically. These functions are present inside the header file called #include stdlib.h. stdlib.h, standard library header file. So all these functions are present inside this header file. Right? Now let's discuss about the functions of malloc, calloc, realloc, and free one by one. So first we'll start with preprocessor data #include stdio.h. Then #include stdlib.h. Fine. First let's go with malloc function. So the execution of the program always starts from the main function. Fine. Now I'll declare a pointer variable int star ptr. So whenever I give this statement, memory will be allocated. So let's take, this is nothing but pointer, allocate a memory. Let's assume the address to be 1000. I'll give the name to be ptr. Fine. This is a pointer variable. I'm done with this. Next, I'll declare few variables int n, I. So n is to get the number of elements from the user. So I'll get scanf %d, ampersand n. So I'll get n value from the user to know the number of elements. Okay. Now I'm going to allocate memory to store n elements. I'm going to allocate memory to store n elements. What I'm going to do is I'm going to go with the malloc function, because malloc function helps us to allocate the memory. First we have to know what is the syntax of this. So the syntax is, so where I'm going to say ptr is equal to cast type. So I have to typecast, because malloc function returns me a void pointer that has to be typecasted. So malloc, this is of what type I'm going to store. So cast type I have to give malloc. Here the size. This is the syntax of malloc. So what I'm going to do is I'm going to store the value in ptr. Okay. Cast type, I'm going to store only integer value. So int star. Cast type I'll give it as int star. malloc. Okay. N into size of int. Okay. malloc function returns me a void pointer. That is why I'm typecasting into integer star. Okay. N into size of int. Let's assume the value of n is 5. Let's assume the value of n is 5. Okay. 5 into size of integer. Let's assume size of integer is 4 bytes. 5 into 4, 20 bytes of memory will be allocated. So allocated memory. It allocates memory in the heap memory. So whenever we are dynamically allocating a memory for a program, the memory will be allocated dynamically. So here 20 bytes of memory will be allocated. Bytes of memory will be allocated. Okay. So in a single block, 20 bytes of memory will be allocated. So let's give the address to be 2000, 2004, 2008, 2012, 2016. So by mistake I have this. I'll remove this. Okay. So 5 into 4, 20 bytes of memory will be allocated as a single block. Done. Now I am going to check if PTR is equal to null. If the PTR value is equal to null, I have to give memory not allocated. So here 20 bytes of memory has been allocated and the allocated base address will be taken and that will be stored in PTR. So here 20 bytes of memory has been allocated. So this base address, what is the base address? 2000. 2000 will be taken and that will be stored in PTR. The base address will be taken and that will be allocated in PTR. Done. Now I am checking PTR equal to null. The PTR value is 2000, that is not equal to null. In case if PTR is equal to null, whenever we are declaring a pointer variable, null value will be stored. So if PTR is equal to null, I'll give a message saying that memory not allocated. And then I'll return. So in this case, PTR value is equal to 2000 because memory has been allocated. So this if condition will not be true. Now I am going to get the input value from the user. Okay. So for int I is equal to 0, I less than n, I plus plus. Scanf %d, comma, where am I going to store the value? So here address of PTR of I. Okay. Here we have to know this is otherwise called as PTR plus I can give. This also works. So this is an array ampersand PTR of I we can give, or otherwise I can give like this PTR plus I. So PTR plus I meaning is, what is PTR value? PTR is having 2000. What is my I value? So here we have to know one thing, that if I give PTR plus I, so it will not take like here. So here PTR value is 2000 plus I value is 0. So 2000 plus 0, it is not taking this value, exact value. In case if it is 2000 plus 2, if assume I value is equal to 2, it will not take the values 2002. So here it will be considered as PTR plus I into size of the data type. This is how it will be considered. Okay. PTR plus I, when I give PTR plus I, here implicitly it is taken as PTR plus I into size of the data type. So when I give PTR value 2000 plus I value is 0, 0 into, what is the size of data type? 4. 0 into 4, which is equal to 2000. In the memory location 2000, I'll store my first value. I'll keep it as 10. That I can give either PTR plus I or ampersand PTR of I. So PTR of I, address of PTR of 0. So it takes this. So both are same only. Now when I go to the next I value, now I value becomes 1. When I value is equal to 1, what I have to give? PTR plus I. PTR value is 2000. I value is 1. 1 into size of integer, which is equal to 4. So 2004. On the memory location 2004, I'll store the second value 20. Then when I give PTR plus 2, so 2000 plus 2 into 4, which is equal to 2008. So the value will be stored in 2008. So this is the difference. So PTR plus I or ampersand PTR of I. Both are same only. Now when I go for PTR of 3, just PTR plus 3, what happens? 2000 plus 3 into 4, which is equal to 2012. So next value will be stored in PTR of 3. Similarly, the last value 2000 plus 4 into 4, which is equal to 2016. Next value will be stored here. 50. Done. Fine. So I've got the input value from the user. Now let's print the value. For int I is equal to 0, I less than n, I plus plus. printf percentage d comma ptr of I. That's all. I'll give return 0. Let me save this and let me run the code. I'll give my n value as 5. I'll get 5 elements 10, 20, 30, 40, 50. See, I've got the values. Now we have to see whether ptr plus I works or not. ptr plus I. Check whether it helps us to get the input value or not. Let me run the code. 5, 10, 20, 30, 40, 50. See, I've got the output value. Now we have discussed in pointers that star ptr. So when I give star something, value at. Okay. Now ptr plus I, we got to know how it works. Now I am going to give ptr star ptr plus I. So we'll see what happens. So ptr value is 2000 plus I value is 0. 0 into size of the data type, that is equal to 2004. Sorry, 2000, not 2004, 2000. Now when I give star, what is the meaning? Value at. What is the value 2000? Value 2000 is 10. 10 will be printed. Now when I give ptr plus 1 of star, so what happened? 2000 plus 1 into 4, which is equal to 2004. So when I give star before this, what happened? Value at 2004, 20 will be printed. So similar like this, here what I can do is star ptr plus I. Let me save this and let me run the code. I'll give size as 5, 10, 20, 30, 40, 50. See, I've got the output value. So ptr plus I or ampersand ptr of I, both are same. ptr of I or star ptr plus I, both are same. So here we are allocating memory by the user and we are storing the elements one by one. Finally, once the program got over, I need to delete this memory. So what function I have to use? I have to use the function called free. Free, which one? ptr. That's all. So whatever the memory I have allocated for this program has been deleted by the end. The program got over. This is how we have to allocate the memory dynamically by using malloc function. Fine. Now let's go for calloc. Now let's discuss about calloc function. So malloc also allocates memory, calloc also allocates memory, but malloc will allocate as a single block, whereas calloc allocates block by block. Let's discuss it. Hash include stdio.h, hash include stdlib.h. The execution of the program allocates from the cut. The execution of the program cut. The execution of the program starts from the main function int main. Fine. So first let me declare a pointer variable int star ptr. I'll give int n comma I. So n is to get the input value from the user, I to iterate in the for loop. So I have declared a pointer variable. So let me allocate a memory for this pointer variable. Okay, so let's assume the address to be 1000 and this is a pointer variable ptr. Done. Initially I'll have the value as null. Now what I'm going to do, I'm going to get the input value from the user. Scan of percentage d comma ampersand n. I'm going to get the n elements from the user. Done. Now I have to allocate a memory. For that I'm going to take ptr is equal to cast type int star. Okay, similar like malloc, we have to give cast type because calloc also returns the value. The major difference between malloc and calloc is malloc will allocate a memory but it stores the garbage value, whereas calloc will store the value is 0. Whenever the memory is allocated, by default it stores the value as 0, whereas malloc allocates the garbage value. That is the major difference, where malloc allocates memory as a single block, whereas calloc allocates memory in a block by block order. So calloc, so how many elements? N elements, comma size of integer. So in malloc I was multiplying so that I'll get a single block of memory. Here I'll allocate block by block. So n value, for example, if I give n value as 5 blocks of memory, each block of size integer, the memory will be allocated like this. For example, 1, 2, 3, 4, 5. So 5 blocks of memory, each block of size integer. This is how the memory will be allocated. So let's assume 2000, 2004, 2008, 2012, 2016. So after allocating the memory, the base address will be taken and that will be stored in PTR. So base address is 2000. So 2000 will be stored in PTR. Fine. That's all. This is how memory will be allocated. After this, by default, it will store all the value as 0. calloc function will initialize all the value as 0, whereas malloc will have the garbage value. These are all the major difference between malloc and calloc. So after allocating the memory, I have to get the input only from the user, before which I have to check a condition. If PTR is equal to null, I can give a message saying that printf memory not allocated. Okay, now I'm going to get the input only from the user. Int I is equal to 0, I less than n, I plus plus. So I can give scan of %d. I can give PTR plus I itself. We discussed how this works. PTR plus I. Okay, it doesn't mean that PTR by 2000 plus I value is 0. No. So when I give I, that I value into size of the data type will be considered by implicitly. Now I'll print the value. I is equal to 0, I less than n, I plus plus. So PTR plus I will give you the address. Now I want to take the value from that address. So I have to give star before this. When I give star, value at. So I'll give printf %d, I'll give space, comma, star PTR plus I. From this address, I'm fetching the value. Then after the program got over, I'm deleting the allocated memory. I'll give free, return 0. That's all. This is how calloc works. Let me run the code. I'll give n value as 3, 10, 20, I'll run the code once again. I'll give n value as 3, 10, 20, 30. See, I've got 3 elements. Again, I'll repeat. malloc allocates as a single block, whereas calloc allocates the block by block order. Malloc will store the garbage value. Calloc will initialize the value as 0 whenever the memory is allocated. Okay, fine. Now let's go for realloc. How realloc works, we'll discuss. Now let's discuss about realloc. Okay, hash include stdio.h, hash include stdlib.h, because I'm using realloc function. Fine. I'll give int main. The execution of the program always starts from the main function. Int star PTR. So I've declared a pointed variable. So let me create a memory for this. PTR. I'll give the address to be 1000. Fine. Next, I'll declare n and I, a variable. So n is used to get the input value from the user to get n elements. I'll give ampersand n. Now I have to allocate a memory. So PTR is equal to int star cast type. I'll use calloc. Calloc n comma size of int. So what happens here? Let's assume the n value is 3. Okay, so 3 blocks of memory will be allocated. So 1, 2, 3. 3 blocks of memory will be allocated. Let's assume the address to be 2000. (2004), 2008. Base address 2000 will be stored here. Done. Memory has been allocated. Now I'll get the input value from the user. For int I is equal to 0, I less than n, I plus plus. I'll get the input value from user. Scan of %d, comma, PTR plus I. Done. So I've got the input values. Assume the input value I'm going to give it as 10, 20, 30. I've got 3 values. Now I need to have 5 elements, but by mistake I have allocated memory for only 3 elements. So in this case, if you want to extend the memory or you have to expand the memory, you can use the function called realloc. Realloc helps us to reallocate the memory. So what I'm going to do is, for PTR, I'm going to reallocate the memory. So first I have to give cast type. Fine. Realloc, because realloc function returns a void pointer, but I need integer pointer, so I am typecasting into int star. Realloc. So for which variable? Pointer variable PTR. How many bytes of memory has to be allocated? 5 blocks of memory. Each one should be of integer. So 5 into size of int. That's all. So now for PTR, 5 into size of integer. So earlier it was 3. Now 2 more blocks of memory will be extended. So it will be 2012, 2016, and the base address will be stored in PTR. So earlier I had the value called 10, 20, 30 here. Okay. So this memory has been extended for another 2 more blocks. So 5 into 4, 20. 20 bytes of memory has been allocated and the base address has been given to PTR. Now I want to store value in these 2 blocks. So what I'll do? For int I is equal to 3, I less than 5, I plus plus. Scanf %d, comma, PTR plus I. So I have got the input value for these 2 blocks also. So now this will be 40 and this will be 50. Okay, now index will 0, 1, 2 I have stored for 3 and 4. So 3 and 4. I have given the condition 4 less than 5, it is true. 5 less than 5, condition is false. I'll come out of it. So I have reallocated the memory. Now I want to print and check whether all the elements have been printed properly or not. So for int I is equal to 0, I less than 5, I plus plus. Printf %d, I'll give a space so that to differentiate the elements, star PTR plus I. Finally, once the program got over, I have to delete the memory, free PTR. That's all, and then I'll give return 0. Let me save the code and let me run the code. So first n value I'll get 3, 10, 20, 30, and then I have to allocate, I have reallocated the memory for another 2 more blocks. I'll give the elements for those 2. See, I've got 10, 20, 30, 40, 50. So n value is 3. First I have allocated memory for only 3 elements. I've given the input value that has been stored in the memory. After that, I have allocated memory for these 2 elements. I have given this as an input value of 5 elements have been printed. Fine. This is how we can reallocate the memory. So here you have to know one more thing. If we can extend the memory, this will be extended. In case if we cannot extend the memory, okay, for example, we'll take a scenario like this. For example, earlier what happens? First I have allocated only 2 blocks of memory. First I have allocated only 3 blocks cut. First we have allocated only 3 blocks of memory. Then we were extending these 2 blocks of memory. Right? In case if we cannot extend another 2 blocks of memory, what realloc function will do in the sense, it will allocate separate memory and it copies the value. This value will be taken and this will be allocated separately, and here it will extend the memory. This is what realloc will do. In case if we cannot extend the memory, it will allocate 5 blocks of memory separately. This value will be copied here and this will be removed. This is how realloc works. And we know free function helps us to delete the memory once the program got over. So when I give free PTR, once the program got over, it deletes all the values, all the allocated memory. That's all. So this is what called as dynamic memory allocation, and here memory is allocated in the heap memory. That's all.